Okay, in Unit 7, Objective 1, we're going to be looking at rules of exponents. Remember the idea of an exponent. The idea of an exponent is that it's talking about repeated multiplication. So let me just put a little bit of an example up at the top so we remember the basic concept. Remember that something like 2 to the 4th power, okay, means that I need to take 2 and multiply it times itself 4 times. The exponent tells me how many times I'm multiplying this base of 2 by itself. So here's the 4 multiplications of the base of 2. We multiply that all out and we find our value to our power. Now we're going to look at rules of exponents. When we have multiple powers in one problem and we want to know how to combine them if at all possible. So we're going to work through a couple examples here to begin with. Our original problem for the first one says x to the 3rd power and x to the 5th. We want to, as you notice, there's a dot in between here, we want to multiply them. And so to look at what that means, we can take this exponent and expand it just like we did above. We did that with our 2, we're going to expand it here. And that's done for you. X to the 3rd means x times x times x. X to the 5th means x times x times x times x, 5 of them. If I were to rewrite that now using exponents, notice it's all multiplication. Here's parentheses, but they mean multiplication. It's all multiplication. It's actually 8 x's multiplied together. And so we can write that using a shortcut of saying x to the 8th power. That's what an exponent means. How many times you're multiplying that base value, that x in this case, by itself. Here's another sample. We have a squared times a to the 4th. A squared is a times a to the 4th is a multiplied together 4 times. Simplifying that, if I count it out, there's 6 a's there. And so we get a, same base, we don't change the base, to the 6th. Okay, let's look at it when the base is not a variable. Instead, it's an actual value. It's a number that we can work with. Here, it's 3 times 3 to the 6th. So 3 is just 3. 3 to the 6th means I have 6 3's multiplied together. Again, multiplying those together means I have 7 3's. So we get 3 to the 7th. Okay, and we can multiply 3. We can multiply 3 to the 7th out using our calculator. Remember that you have that caret key on your calculator. So let's look at how we enter this in. I'm going to move it up so you can actually see my fingers. Hopefully you can actually see the calculator. Let's see if I can move it around a little bit. All right, so if I enter this in, I want to type in a 3, and then I want to use this caret key. Okay, I know you can't see my screen very well, but we're going to go ahead and see my fingers. You do it on yours. Use that caret key. And we put 3, and it gives you an exponent. Now we can see that there. It actually shows you that you're entering an exponent, and we want to type in our exponent of 7. So we type in our 7, we hit enter, and we get 2,187 as the actual value for that exponent. Now be careful. Notice that base of 3 did not change. It is a bunch of 3's multiplied together, so we want to get our value as 3 to a power. Okay, now it's our turn to actually work through and try that ourselves without the expanded part written out for us. And so I'll do one, and then I'm going to have you finish the rest of it. First one, x to the 4th times x to the 3rd. Now you try it. Write out the expanded. See how it looks here? You're going to write your own. Put your x to the 4th in. Then put in x to the 3rd. And then simplify it. Okay, go ahead and pause it so you can finish that, and then I'll show you the worked out solution. Okay, welcome back. So we have x to the 4th, 4 x's multiplied together with 3 more x's, because that's our x to the 3rd. When I multiply that together, I have 7 x's, so I have x to the 7th. Here, if I multiply, it's 2 squared times 2 to the 5th. Why don't you try working that out again? Pause the video so that you can try it on your own, and then come back and check your answer. Okay, hopefully you've already done this. So we have 2 squared, 2 times 2. Multiplied with 2 to the 5th. Oops, not 5, 2. There are 5 2's there. So we have 2 2's, 5 more 2's. There's a total of 7 2's. So we have 2 to the 7th power. All right, the next one says x to the 32nd times x to the 51st. I don't know about you, but I'm not about to write out 32 x's and then 51 x's. Let's think about what's going on. What do you notice here? We had 2 here, 5 here. The total amount came out to 7. To find a total, what do we do? Hopefully you're thinking add. To find our total amount of x's, if there's 32 here and 51 here, finding our total means we need to add together the total number of x's. 32 plus 51 x's gives me x to the 83rd. There are 83 x's there multiplied together. So that gives us our first rule, that basic idea that when you are multiplying two powers that have the same base, a base of x, or a base of 2, okay, or up here, a base of a, we simply need to add the exponents. So if I have x to the a multiplied with x to the b, the general rule is to take those two exponents and add them together to get the exponent on my final answer. Notice the x doesn't change. So I get x to the a plus b. That's our rule called a product of powers. Okay, our power a to the x to the a times a power of x to the b gives me an x to the a plus b, the sum of those two exponents. Okay, now it's your turn to try again, so try the next 3 problems and then start up the next video once you've done that.